In this video, I take a look at the Heathkit HD-15 hybrid phone patch. A phone patch is a circuit or device that allows connecting a two-way radio to a telephone line so that a conversation could be made by radio with someone on the telephone. They were commonly used by amateur radio operators before the prevalence of cell phones, as well as by commercial and military radio. If you watch the television show MASH, for example, you might recall scenes where military personnel made a call back to the USA from Korea via the MASH unit's radio. A phone patch would have been used on the other end. A phone patch connects a radio transmitter and receiver, or transceiver, to a two-wire analog phone line. They typically provide facilities for controlling the receive and transmit gain levels, and a meter to indicate the levels. If the radio uses voice-operated transmit, or VOX, it needs to ensure that the received audio doesn't feed back into the microphone input and inadvertently trigger the transmitter. The HD-15 hybrid phone patch was sold by Heathkit from 1965 to 1983 at a typical retail cost of $24.95. It was sold as a kit that the user would assemble and included a detailed manual in all parts. It replaced the earlier HD-19 phone patch, which was very similar in functionality but had different styling. The HD-15 matched the look of the Heathkit SB series radios and could be directly connected to an SB100 or SB101 transceiver, or an SB400 or SB401 transmitter, and SB300 or SB301 receiver. It could also be connected to other Heathkit and non-Heathkit equipment, as documented in the manual. When Heathkit introduced the SB630 and SB634 station consoles, they integrated the same phone patch functions into these units using similar circuitry. In 1985, Heathkit introduced the HD-1515 solid-state patch, which had different styling and circuitry. It was offered until 1989, when Heathkit stopped developing ham radio products. The unit is quite simple to use. It connects to a phone line as well as the speaker output of a receiver or transceiver and microphone input of a transmitter. It also connects to the radio speaker. When turned off, it's disconnected from the phone line and it routes the receiver audio to the speaker. When turned on, it enables the connections between the radio equipment and phone line. The meter indicates the incoming and outgoing audio levels. Separate controls adjust the receive and transmit audio levels. The levels as indicated on the meter should not exceed 0 dB in order to comply with phone company requirements. These controls are on the front panel. On the rear panel, we have the following, from left to right: phone jacks for the microphone input, either high impedance or 600 ohms. The choice depends on the type of transmitter being used. A terminal strip with connections for ground, loudspeaker connection output, receiver loudspeaker output, and two connections to the telephone line. A null adjustment needs to be done after assembly. It uses the null monitor switch and the null adjust trim pot. I'll describe these later. Note that the unit doesn't use any active components, tubes or transistors, so it doesn't need any power source. The Heathkit manual shows how to connect the unit to Heathkit SB series equipment, as well as some guidance on how to connect it to other radios. Inside, all circuitry is point-to-point. It includes the meter, function switch, transmit, receive, and null controls, and two transformers, along with some resistors, inductors, and capacitors. The Heathkit manual has a large fold-out schematic as well as theory of operation. One transformer provides the 2 to 4 wire conversion between the phone line and radio, and another provides the isolation and impedance matching to the transmitter microphone input. In order to support VOX mode, the unit needed to cancel out any speaker audio signal from the microphone input. The circuitry to do this needed to be adjusted for the specific phone line and radio equipment being used. You would tune the radio to a constant tone and then adjust the null adjust pot when the null monitor switch was in the null position for a minimum reading on the meter. This would be done with a phone call in progress. Once set, it didn't need to be adjusted again unless the unit was used with a different radio or phone line. I bought this unit on eBay from a seller in Ottawa that I've bought from before. The unit was in very good condition cosmetically and came with an original manual. Looking inside, the original kit builder had done a good assembly and soldering job, and all parts appeared original and unmodified. I performed some light cleaning of the case and knobs. I performed the suggested resistance checks in the manual and checked the resistor and capacitor values. They were all within tolerance. And I confirmed that the meter moved freely. The original manual is complete and dated 1965. The cover is stamped with what is presumably the name of the original owner, R.J. Saylor, V3MTD, and an address in Guelph, Ontario, Canada. According to Industry Canada, that call sign is now registered to someone else. A Google search did find a few references to the original owner in some ham radio magazines and scientific journals between 1980 and 1990, and it appears that he was a scientist or engineer in the field of materials research, calorimetry, and thermal analysis. In theory, I could use this with my Heathkit HW101 transceiver. Heathkit published a technical bulletin describing how to connect it, or with another transceiver, but I don't have an analog phone line in my house anymore. While in the 1960s and 70s many hams would have owned a phone patch, they tend to be rarely used today due to the prevalence of cell phones, although many ham radio repeaters still have active phone patches. Some hams have modified and repurposed units like the HD-15 for use as an audio interface to a computer sound card for use with digital modes. Here's one such circuit. Other than that, the units are more of historical interest, and I found it fascinating to learn a little more about how they were used and the circuitry involved.